All right, gentlemen, why don't we talk about the pattern we're seeing here? Because I did it with you guys. So what are we saying, Schweib?
Well, we're saying that it's doubling each time and it gets exponentially bigger.
Let's, Sarkis. So this is what I start with, a penny. Wouldn't day 2 be here? And day 3 be here? So notice. So what would day 30? Notice on day 3 is here at 4 cents. Day 3 is at 4 cents. Day 4 is at 8 cents. Day 5 is at 16 cents. So what would day 30th be in exponential form? What is day 1 in exponential? What?
2 to the 30th.
No. What am I having on the first day?
1 cent.
Right. So I'm here. Notice my exponent. So on day 2, what do I have in my account?
You have
2 cents, right?
yeah.
But exponentially, what is it?
Is 1 to 2 first 0 to the power.
On day 3, what do I have?
2 to the
Right. On day 4, what do I have?
2 to the third power.
So what would I have on the 30th day?
2 to the
2 to the 29th power. So if you put that in your, what do you get?
You get 5,368,700.
It's not 5 million. You get 5, what?
Well, no, in dollars.
2 to the, I asked you what 2 to the 29th is.
Okay. If you want to do 29, that's I did. I don't believe you. 536,870,912.
Hold on.
536 million.
536. Shh. Keep going.
536 million, 870,912 pennies.
Okay. These are all pennies. How do I convert that to dollars?
Divide by 100.
Divide by
100.
100, and that would move my decimal 2 times. So it's $5,368,709.12 if you get a penny every day and it doubled for a month versus the $1 million. So why don't you go home and ask your parents that? So, shh. This is excuse me, I'm recording. This is part 2. So what I wanted to bring up is, notice in the beginning we had very little amount of money. In the very beginning we had very little. But in the end, see how big these jump between points? So if you're ever offered a deal in and of itself, if you look at any function we have, the one that multiplies the fastest, that increases the quickest, is an exponential function, not a quadratic, not a linear. Like in the quadratic, remember it was like 2 little points together at the bottom, and then it kept going. But it looks like it moves slower and slower towards the beginning. But you see, your money increases, and if you have money that can increase exponentially, it will grow the fastest exponentially. This is why credit cards get people into so much debt, because it increases exponentially. All right. So now let's go to domain and range. Ellen, you were asking about that. Let's also talk about a little bit about this exponential function, since we haven't talked about them. With exponential functions, it will get closer and closer to 0, but it will never actually touch 0. And it increases the greatest out of any kind of function. So, you'll see, why will it not get less than 0? Because look what happens. If it less than 0 implies a negative number. When I have a negative exponent, that only makes it fractional. So it doesn't matter. I could have 2 to the negative 223rd power. It's still going to be a fraction. It's not going into the negatives. It's never going to get lower than 0. Yeah.
Is there a certain point where an exponential equation will start to look like an equation with no slopes? Like a vertical one?
No, it will never. It will always have.
It will always have some kind. It may appear, but you can't look at what appears. All right. So what is my domain here? The question is, state the domain. State the domain. Pausing it. Remind me to record. State the domain. State the domain. Come on, guys. Domain is width. How wide is it allowed to go? Ellen? So we would say x is such that x is any real number. Is it a function?
Yes.
Passes the vertical line test. So the d is equal to x is such that x is any real number. What about the range? Y? Y? How high can it go? How low can it go? Okay, Olivier.
X is greater.
It's not x. When we talk about range, we say y.
Oh,
Shh. Did you hear that? When we say range, we say y.
y is greater than 0.
Y is greater than or equal to, no, y is greater than 0. Greater than 0. Right. So y is such that y is greater than 0. Okay, you getting the idea of exponential? Okay, do I have 8th graders in here? This is a big one for you. This is a big one for you. They're going to have you comparing functions. The thing you have to remember, we've learned about linears. Y equals x. We've learned about quadratics. Y equals x squared. We've also now just learned about these exponential. I don't know how to make that. It kind of starts low. Okay, which one always increases the quickest, the fastest? Exponential. You have to look at the picture. Now, even if they mix them all up, we could take a graph, okay, let's call this line number 1, number 2, number 3. Which one increases the fastest? 3. Because it's exponential. It's getting steeper faster. Okay? So you have to be able to analyze those. 7th graders, you need that too. But 8th graders. All right. That was 12-2. Part 2.